given an n by n matrix with x's and o's, we want to capture regions that are surrounded. So basically, um, like regions are O cells, or adjacent O cells,
Mm.
and then surrounded by X cells. So basically, we want to um, let's see. So we want to. Oh, okay. I see what's going on. So basically, if we have any O cells, aka regions, which are completely surrounded by X cells,
Mm.
what we can do is replace all of the O cells, all the region, with X cells. So what that would look like is, so let's use this example here. Um, Okay, thank you.
Yeah.
So basically, as we can see from this example, we have two, we have a O here and an O here and an O here. And basically these three connect to make a region. Note how this doesn't cover the O in the last row because it is not vertically or horizontally adjacent to any of the other O's.
Mm.
Um, so what we want to do is if this region of O's is surrounded by X's, we want to replace all of the O's with X's.
Mm.
And yeah, sounds good. And yeah, so we don't replace the O in the last one in the output.
Mm.
Sounds good. So let me just ask some clarifying questions. Um, we know that the matrix only contains X's and O's, correct?
Yeah. Yeah.
Sounds good. And we don't want to, obviously for any O's on the edge of the board, so like the borders of the board, right? They
Yeah.
cannot be replaced any way, shape, or form um because it has to be at all X's surrounding it, right?
Yeah.
It
Yeah.
can't be like nothing. Okay, sounds good. I think my first approach, when I think about a solution, would be to do a brute force traversal for every single O that I find.
Mm.
So what I would want to do is I would do a traversal, either BFS or DFS. When thinking about which one to use, I think I would go with the BFS because I want to um like the regions are connected to each other. So to do in the region.
Mm.
Did I cut out?
Yeah. You cut out a little bit, but
Oh, sorry. Can you hear me now?
yeah, I kind of got.
Okay, yeah. So basically, I want to do a BFS for every O, and I just want to find where all the O's are. So if I started traversal at this O, for example,
Mm.
I want to try and find all the other O's that I can reach. So I would reach all of these, and then once I hit a point where it's surrounded by all X's and any O's that I've already visited. So for example, if I start at this O, I would traverse to the one on the right
Mm.
and then the one down from there. And then I would also have a set to keep track of which coordinates I've already reached.
Mm.
That way in my traversal, I don't go backwards and hit a cycle.
Mm.
So once I finally reach the end of my region, so the last O I would visit in my region,
Mm.
which would be surrounded by X's and O's I've already visited. what I would want to do is I would start replacing all of the O's that I visited in my visited set
Mm.
with X's. And yeah, I think let's see if that covers all the edge cases. So
Wait,
I
so
guess yeah.
just out of curiosity, what would the
Mhm.
time complexity of this be?
Yeah, time complexity here would be, um, or let's also add a component I forgot to mention earlier. Let's add so we have like a visited set for every traversal, right? Let's also keep track globally of every O that we have seen.
Mm-hmm.
So like everyone we've accounted for. Actually, no, we don't even have to do that because once the traversal ends, right, we've already replaced all of the O's in the region with an X, right? So
Mm-hmm.
let's say if we start traversing with this O, and then we finish traversing, so we've replaced this O, this O, this O with X's, there will be no more O's here to check. So the overall time complexity would be um, let's see. It would be O of n squared because for every single cell, we have
Mm-hmm.
to check if it's an O. And then in the worst case, we will be doing a traversal with for all the nodes for that.
Mm.
The space complexity would be O of n because we'd use a either stack or queue to do the traversal.
Mm.
Does that sound okay, or are we looking for something a little more optimal?
So what you described should make sense. It's also what I thought of initially while doing this also, but
Mm-hmm.
there is a solution that is O of n.
Oh, I see.
So um so basically what you're saying is that you're traveling through and for every single O, then you're then you're basically like traversing and checking to see if it's rounded, right?
Mm-hmm.
That's what makes it n squared. Um so is it necessary to like check for, I don't want to give it away, but um is there like another way that you can break it down?
Yeah, for
Besides
sure.
like yeah.
Let me think about this. So right now we're doing it in O of n squared, which seems to be a little slow. Is there a way we could do it faster? Let's see. Hmm.
Like the solution isn't super complicated. Like it's along the same thing. Maybe instead of like a BFS, think of like something else that you could use.
Okay, sounds good. Um, let's see. What if you used, or DFS would also be, um, I guess we could do DFS instead and just, but it's
Mm.
still the same concept, right? We're just following the O's.
Mm. But then like once you encounter an O, what do you want to do with it again?
Once we encounter an O, we want to um keep traversing it. So basically um like a post almost like a post order traversal for trees. So basically we want to do a DFS all the way till the end, right?
Uh huh.
And then if we can find an end where it's surrounded by X's and O's that we've already um reached, then we would start replacing them backwards with X's.
Mm.
So like what I'm saying is if we let's just copy this for sake. So if we had something like this, right? We'd start at this O, and then we keep going. So let's move to the left, right here. So now that we're at the one on the right, we're gonna check the neighbors. So up, left, right, down.
Mm.
Up and right are X's, so we don't want to visit that. The one on the left we've already visited, so we have a set to keep track of that, right?
Mm.
So the only option is go down, and once we go down, we'll find that everything's an X and we have basically have nowhere else to traverse, right? So what
Mm.
we're gonna do is we're gonna start replacing these with x's. So we can have like a recursive function that calls DFS first
Mm-hmm.
and then replaces with X.
Mm-hmm.
But that is still, like we mentioned earlier, that is
Mm-hmm.
still O of n squared. So let me think if there's a maybe a better way.
Would introducing some sort of temporary variable help at all? Like in reducing the time thing? Because I guess what you want to capture is the unsurrounded regions. Then you want to capture surrounded regions, right?
Hmm.
And then like yeah, like is there some sort of like temporary variable that you could introduce to make that a little bit easier? Or
Okay, temporary variables. Let me think about that. So if we introduce a temporary variable, uh,
so what O's cannot be flipped to X?
basically anyone on the edge.
Yeah. So you wanna mark that somehow and say that you can't turn those into it, right? S-
Right. So we'll
So
probably have like a maybe like for every O that we encounter, we can check if it's on the edge.
mhm.
And if it's on the edge, we just wouldn't even call it BFF. We would just wouldn't traverse that one at all.
Or okay, wait, so why would you not want to call it for the edge one?
Because we know that that one could never be replaced.
Yeah. So is there a way to mark that so it could never be replaced?
Oh, I kind of see what you mean. So
Mhm.
basically marking the ones that can't be replaced. Oh, I see. Oh,
Oh,
okay.
it sounds
Yeah, I
promising.
think I get it. Yeah. Um, okay, yeah, thanks for the hint. So
Yeah.
basically what you're saying is let's work backwards. So instead of looking for the ones that we can replace, let's look for the ones that we cannot replace, right?
Mm.
So I guess what you're saying is let's just replace every single um let's replace every single um O that's not connected to the edge into an X, right?
Mm.
But we also have to consider the O's. If there's any O's on the edges, we would do a traversal for that and then keep any of the ones that we traverse. So, for example, if this one was an O, right?
Mm.
We would do a traversal starting from the edge because we know that the edge can never be replaced, right?
Mm.
So we would do a traversal, DFS, BFS, that either works. Um, we do a traversal, and then all the O's that we reach, we know those cannot be um, replaced.
Mm. Yeah.
So what we can do is we could just do a traversal starting from every edge,
Yeah.
or not starting from, yeah, basically starting from every edge cell, and then we would only do a traversal if it's an O. So basically two requirements. It has to be on the edge
Mm.
and it has to be an O.
Yeah.
And then from there we do a traversal. As we traverse, we keep track of all the O's we visited, and then we'd make sure not to replace those with X's.
Mm. That's
Does that
yeah.
sound like a better solution?
Yep, that sounds really good. And you can assign it to
Okay.
like anything, right? Like as long as but you have to make sure to convert it back to an O afterward, right? Cuz
It, exactly.
yeah.
Yeah. So yeah, we just wouldn't change these.
Yeah, yeah.
Yeah. But then everything like what we could do is like coding wise, what we could do is we could add every O we visit to a set,
Yeah.
and then at the end we could do a traversal through the whole matrix and then replace any of them.
Mhm.
Replace all the ones not in the set with an X.
Yeah. So that would work and yeah, it would work, but is there any way to make it slightly more space efficient? It's like you're like on the completely right track. Like instead of a set, what could you do?
Slightly more space efficient. Okay, sounds good. Um, what we could do is instead of using a set, so if we don't want to use a set, what we could do is um maybe replace it on the spot. So what I'm thinking is, let's see, can we replace it on the spot? So as we're doing the traversal, um, oh, I see what you mean. Yeah, so we just replace it on the spot. So maybe we could, instead of using a set, so like extra additional memory, we could just replace these O's with like a different character. So maybe replace it with like, I don't know, like a Z. And then
Mm.
once we do the traversal, instead of checking if it's in the set, we can just replace all the O's to X's and not the Z's.
Mm-hmm.
So I think that's what you meant by like
Yeah,
temporary variable.
yeah.
Yeah, okay,
Hey,
sounds good.
genius, bro. Genius, genius.
Yeah.
Yeah. Okay.
Thanks for the hint. I guess I could try coding that up
No,
really quick.
dude, that wasn't. Yeah, that wasn't a hint, bro. You figured that out yourself. Okay. There you go.
Okay, let's call this. Do you want to paste the thing really quick?
Sure, sure, sure. There we go. Oh, copy. What the? Okay, wait, give me a second.
No worries, take your time.
Um, what's wrong with my copy paste? If I. Okay, there we go. Solution. Okay, there we go.
Nice. Okay.
Ignore that.
I guess I should have added some pseudocode, but yeah, let's do all the edges, right? So
mm.
let's have a function called DFS. I guess in the end we chose to go with DFS, but so we'll pass in the coordinates of our current cell. Um, let's see. So what we want to do is if I is less than 0, so basically just the edge check, or I is greater or equal to length. Let's get m and our dimensions down. So let's do m equals length of board, n equals length of board 0. So this is our row and column, max row and max column. If that or j is less than 0 or j is greater than that, what we can do is just return. And then what we want to do is, let's also do the check where board ij is not um, an O, right?
Mm.
So if it's not an O, we just want to check it. So let's do this. It's called so first we gotta set it to something, right? So let's set it to like we said Z. I'm just thinking of a random
Mm-hmm.
letter, right? Z, and then let's call DFS on all the neighbors. So let's do
Mm.
left first. We got right,
Mm.
up, or sorry, up, and then, or sorry, this is right, and then this is left. So that'll be your DFS function, and then what we want to do is we want to start checking from all of the edges, right? So to do that, we can do the top row and bottom row first. So let's do for I in range length, or not, but n. So that would be all of these, right? What we want to do is we want to if or we don't even have to do the if check because our DFS function does that for us. So we can
Mm-hmm.
just do DFS I of 0 or 0 I. So that's
Mm.
going to be everyone at the top. And then for the bottom ones, we could do so the bottom row would be m minus 1,
Mm.
m minus 1 I. And then we want to do this for left and right as well. So I range m DFS I0, DFS n minus 1, or sorry, um, I n minus 1. And then at the end we also have to do for I in range. So basically go through every one and replace all the O's
Mm-hmm.
to X if because we've already placed all the ones we can't reach with a Z.
Mm-hmm.
So let's do for I in range M, for J in range N. Oh, we also have to replace the Z's back to X's. Or back to O's, sorry, back to O's.
Wait,
So
wait. So for this one, it's you're only doing like four, like on the edges. You mean, right?
yeah.
Is there like so for the problem, is it only the edges that you want, or like what about like an O like this?
That's an O on the edge, right?
Oh wait, no, maybe I'm just thinking of it wrong. It's like oh sorry like okay, like does this grab that one?
It does, yeah, because this would be the bottom row, and bottom row would be n minus, like DFS n minus 1, and then I.
But that's just the coordinates for this one though, right?
Yeah, that's the coordinates for that. So basically, it start checking from here.
Oh okay, I get it. Yeah. Okay,
Yeah.
whatever. Yeah.
Yeah, so let's go back to the board. If board ij equals O, board, replace it with a X row. Um, Elif board ij equals Z, then replace it with an O. And that should be it. And I guess we return. Oh, we don't return anything. Yeah, this should be our thing.
Hmm. Um.
Let me know if that makes sense.
Yeah, it makes sense. Okay, so for here,
Hmm.
like so you're saying you can do this all like simultaneously. Oh, okay, I see. Yeah, yeah,
Yeah.
yeah. So for 4C, okay, this should work. Okay, unless I'm mistaken, it should work.
Yeah. I don't know. There might be some syntax errors. There's always some syntax errors.
Let me see.
Okay, I'm stopping the interview.
Okay.
That was like 23 minutes. Not bad.
Yeah, that's not bad.
Yeah, this was a really fun question.
No, like I thought you like it because we did the Pacific Atlantic flow yesterday, and then this is like
Yeah,
a
yeah.
variation of it.
Dude, this is literally you just have to work backwards.
Yeah, it's like the thing what we said yesterday.
Yeah, literally always. Thanks for the hint. I wouldn't have got it without the hint, to be honest.
So I wouldn't have come up with it either. I
Yeah,
thought you
just
told me when I
always
was like,
work
bro.
backwards. Damn.
Yeah. Wait, there's object of type int has no length on this line. I'm trying to figure
Oh,
it out too.
replace this with just remove the len.
Oh, okay.
Yeah, I trolled.
Here we go. Same thing with n. Move on this again. Oh, accepted for the first two test cases.
Nice.
Goaded. It's 100%.
Nice.
Nice.
Good job. Thank you, man. Thank you.
Yeah.